This is Algebra 1, Unit 8, Lesson 5, Stretching Parabolas and More Completing the Square. So we have seen the leading coefficient a of a parabola does some interesting thing. Y equals ax squared plus bx plus c. A is right here. If the a value is positive, which way is the parabola going to open? It opens up. So the parabola is going to look like this if your a is positive. If your a value is negative, the parabola is going to open down. So that means it's going to look like this. It's going to be, the endpoints are going to be going down like this. Okay, so A is important because it tells us which way the parabola opens, but it also does some other things to the parabola. Let's take a look. Okay, now, use your calculator to sketch a graph of each of the given axes, label each with its equation. All right, I put this in my calculator, and I'm going to graph one at a time so you can see them. You can also do this on decimals if you want to try it out yourself. Okay, so we go to y equals. I'm going to shut off the rest of these for right now. So enter, enter, and enter. Okay, so I'll just graph y equals x squared and take a look what that looks like. All right, so y equals x squared is going to be the blue graph. Let me draw that on my paper. Whoops. So I'll even do it in blue so you can see it. All right, so y equals x squared looks something like this. It goes up, matching on both sides. Pretend that I can draw a straight curve. So this is y equals x squared. Okay, so let's compare what happens when we do y equals 2x squared. All right, so I'm going to leave y equals x squared on there, and now I'm going to turn on y equals 2x squared. Okay, that's the red one. What happened to the parabola? Well, it looks like it got narrower. All right, let me draw the parabola on here. All right, let me do it in red so it looks like what's on the paper. So y equals 2x squared looks like that. Okay, so y equals 2x squared looks like that. All right, y equals 4x squared. What do you think is going to happen there? Well, let's try it out and see. Y equals 4x squared. I'm going to go down to this one and graph it. Oh, it got even narrower. So you can see right here, it's the black one on there. So that became, I have a black one here, even narrower like that. So we can see what's happening with the leading coefficient. All right, so that's that one right there. That's y equals 4x squared. So it got even narrower. Okay, so that tells us if the a value is greater than 1, the parabola will get narrower, narrower. Will narrow. It gets thinner. Whoops. It will get narrow. Okay. All right, so it gets smaller and smaller because what's really happening is, as if you're comparing this with x squared, you're going up even faster the bigger the number is going to be. All right, now, let's try y equals 1/3 x squared. Let's see what happens with that. Let me go to my calculator. Here's y equals 1/3 x squared. Oops, I got the wrong one. Sorry. Y equals 1/3 x squared. Let me turn that one on. Oh, it's this purpley pink one here. So that is going to look like this. Purpley pink one. It kind of goes down like this and around and goes like that. All right, so that's y equals 1/2 or 1/3 x squared. That's a 2. Okay. All right, so that means if this is a fraction, if the a is between 0 and 1, a fraction of 0 and 1, it's going to, the parabola will widen out. And it flattens. So it's as if you took the original one and squished it down. And you end up with the flatter parabola. Because this is not going up as fast as these, because 1/3 is a smaller number, it's not going to increase or decrease as fast as the other one. All right, so the a value tells us which way the parabola opens, up or down, but it also tells us how wide or how narrow it's going to be. So if the a value is greater than 1, it's going to narrow up. The bigger the number, the narrower it gets. And if it's between 0 and 1, which means a fraction between 0 and 1, it's going to flatten out and may be wider. Okay, so let's see if we can pick out the values that work for this. Okay, so we have this picture here, and we're going to write the number of each equation besides its curve. Okay, so we have 3 parabolas that go up and 2 that go down. So let's start with the ones that go up. What kind of a leading coefficient should we have, positive or negative? It should be positive. So number 1 should go up, number 2 should go up, and number 4 should go up. So let's take a look at those two, 1, 2, and 4. All right, so we have 3x squared, 1/2 x squared, and x squared. That's my 3 that I have to work with. Okay, so looking at this one right here, the narrowest one of those 3, which one is it going to be? Well, that's going to be number 1 because the leading coefficient is greater than 1. All right, so that means that's got to be the narrowest of the graphs. Okay, so 1/2 x squared should be the widest of them because it has the leading coefficient less than 1. All right, so that probably is going to be number 2 over here, which means this one in the middle has to be number 4. So you can see that these 3 are opening up. Because of the leading coefficient, we can see this is really 1x squared. So this one is narrower than the 1x squared. This is wider than the 1x squared. Okay, so that leaves negative x squared and negative 2x squared. That's these two down here because these two open down. So that means one of these is x squared and negative x squared, and one is negative 2x squared because they both open down. Okay, so which one would be negative 2x squared? Would it be the inside one or would it be the outside one? It would be the inside one because that means it's narrower because this value is negative 2. The 2 value is bigger than 1, so that means it's got to be narrower. So that means that this one is actually going to be number 5 because that's y equals negative x squared. All right, so we've learned lots of stuff about the a value of a quadratic. So be very careful when you do this. Okay, now we can still use completing the square to put the quadratic in vertex form even if a doesn't equal 1, although it is a little more complicated. All right, so there's just basically technically 2 extra steps that you have to do when you do this from the process of completing the square that we learned the other day. All right, now, to complete the square, the ones we've done so far have always been x squared. Well, this is 2x squared. So what we have to do is divide the whole equation by the leading coefficient to make the leading coefficient x squared. Now, if I do that over here, I also have to do it on the other side. Don't worry about leaving this as y over 2 because we will fix that later. All right, then 2 divided by 2 is just going to be x squared. That's what we wanted. Negative 12x divided by 2 is negative 6. And 11 divided by, negative 6x. 11 divided by 2 is 5.5. Okay, it's okay to have decimals. We'll deal with those later. All right, so once we get to this step, it's just like we did completing the square the other day. We subtract the c term. So we want to move the c term to the other side of the equation. So if I'm moving this one, I've got to move it over here as well. Remember, just going to leave this as y over 2 for right now. We'll deal with that later. So we have y over 2 minus 5.5 is equal to x squared minus 6x. Okay, now, this is where we do the complete the square. We want to take half of the b term and square it. What's half of the b term? Well, remember, this is the b term. Half of it is going to be negative 3, but then we want to square it. And we want to do it here, and we also want to do it over here. All right, so what's negative 3 squared is 9. So this is minus 5.5 plus 9 is equal to x squared minus 6x plus 9. All right, when I combine my terms here, I get y over 2 plus 3.5. Plus 3.5. All right, now x squared minus 6x plus 9 is what perfect square trinomial? Remember, the perfect square trinomial is whatever we took half the b of. So this is going to be x minus 3 because this will match that when you do this. All right, now we have to move the 3.5 back to the other side, move the c term back to the other side. So we completed the square and moved the c term back. So that gives me y over 2 equals x minus 3 quantity squared minus 3.5. Okay, now here's the second step that we need to do. re-multiply the whole equation by the leading coefficient that you divided out in the first step. So what we need to do is we need to put a big parenthesis around this and a big parenthesis around this entire thing right here. So I want to multiply both sides by 2. Since I divided by 2, I'm going to multiply by 2. What that does is it cancels out the 2's, leaving just y. Now this 2 has to multiply to this, and it has to go to this. All right, but we can't multiply through the parentheses because of the squared here. So we just take the 2 and we put it in front of the parentheses. That makes it the leading coefficient, and then we do negative 3.5 times 2, which is negative 7. Okay, so now we have our our completing the square. We have created vertex form of this equation. Y equals 2 times x minus 3 squared minus 7. 2 is the leading coefficient. See the 2 here? The 2 is leading coefficient, so it tells us which way it opens and what to and how narrow or how wide it's going to be. Now, what else does it tell us? What is the vertex of this parabola? All right, don't worry about the leading coefficient. The vertex comes from this and this. So what's your vertex going to be for this? Well, let me move it down. All right, so this is y equals 2 times x minus 3 quantity squared minus 7. So that means that the vertex is going to be 3, because it's the opposite sign, negative 7. Looking from this here, the vertex comes from this, opposite sign here, same sign there. So that's going to be the vertex from what we learned previously. Okay. All right, so why don't we stop right here and we'll finish the notes tomorrow.